So in my problem for resistors in parallel, I have a 9-volt battery that is connected to 4 resistors, and I'm going to find the equivalent resistance for the circuit and the total current through the circuit. So first I am given the value of the volt, which is 9 volts. My first resistor is 2 ohms. My second resistor is 4 ohms. My third resistor is 5 ohms. And my fourth resistor is 7 ohms. Now I'm going to be looking for the resistance total and the current flowing through. Now the difference between parallel and circuit, in a circuit you can just add all the resistances together to get the total. For parallel you have to do their inverses and then add them all together. So I'll need to do 1 over 2 plus 1 over 4 plus 1 over 5 plus 1 over 7, and then that is how I will find 1 over RT, but then I just can find the inverse of that to get me RT. And when I add them all together and do the math and get the inverse function, it is going to equal 0.917 ohms. Now I do the same thing that I did in series in parallel to find the current. I equals the change in V over R. So 9 over 0.179 is going to give me I equals 9.8 amp is my final answer for the current flowing through this circuit. And the potential difference for each voltage drop is 9 volts because each voltage drop is the same at each resistor in a parallel sequence. So these are some basic characteristics of resistors in parallel. That is a basic schematic diagram of what a parallel resistor should look like. The currents in a parallel resistor are going to be added together to get the current total. For the potential difference, the total voltage is the same for every voltage drop on the schematic. And the equivalent resistance is 1 over the resistance total equals 1 over R plus 1 over 2 plus R3, and so on and so forth to get the total resistance.